Hey there, everybody. Welcome back. This is 6.6. We just got done looking at seeing if two lines were parallel, perpendicular, or neither. Now we're going to find lines that are parallel and perpendicular to a given line. All right. So, write the results in standard form. This is good algebra practice, manipulation and stuff. We're getting near the end of the semester. It's good to keep you on your toes. So we are going to start with example 1. Y equals negative 1/5 x plus 7. And we want lines that are parallel and perpendicular to this line through the point. And in this case, the point will be -10, -3. So for the parallel line, M1 equals M2. So our new line will have a slope of -1/5. For the perpendicular line, M1, the way we show this in the equation form would be like this. We're doing the opposite reciprocal. So we flip it over and we make it positive. It's +5 for the next slope. This might look better if I say M2 equals -1 over M1. So working through this, we've got a point and we've got a slope. Y minus Y1 equals -1/5 x minus x1. Y minus, let's see, Y1 is -3 equals -1/5 x minus -10. So this is Y plus 3. Since I need to write in standard form, it's easy to clear the fractions now. So the only denominator I have is 5. So I will multiply both sides by 5. This becomes 5y plus 15 equals -x plus 10, which is -x minus 10 if I distribute. So I will add x to both sides, and I will subtract 15 over, and I get x plus 5y. -10 and -15 is -25. We do the perpendicular line. We have y minus y1. Again, this is -3 equals, our slope now is 5. X minus x1 is -10. So it's already got a pot, no fractions. Now I'll just distribute. Subtract 5x over, subtract 3 over to get the constants on the right. I have -5x plus y equals 7. And it's actually customary. Customary is to have for ax plus by equals c. A lot of people do a greater than 0. So I'm going to multiply this by -1. Multiply both sides by -1. This becomes 5x minus y equals -7. Okay. That's our first set. Let's give you guys one to try. So example 2, this is your walkthrough. Y equals 3/4 x minus 11 through the point 92. Oh my gosh, I have an itch. Where's my ruler? Oh yeah. Oh, that hits the spot right there. Whew. All right, I will assume you did it. For our parallel line, the slope is the same. For the perpendicular line, the slope is the opposite reciprocal. So let's just start plugging in and see what we get. Y minus y1. Notice I don't need the negative 11 anymore. When I did the last one, we had the +7. The +7 never came back up. We don't need that anymore. And that +7 is specific to that line. All we need was the slope. That's all we need here. So y minus y1 is y minus 2 equals 3/4 times x minus 9. I will clear the fractions by multiplying by 4. I get 4y minus 8 equals 3 times, this becomes 3 times x minus 9, which is 3x minus 27. I actually think it's easier to keep the 3x positive rather than multiply by a negative later. I'm going to subtract 4y over here, and I'll add 27 to both sides. If I do that, 27 minus 8 is, well, 27 minus 10 would be 17. Add 2 more is 19. And then this is 3x minus 4y. And if I want to have it look where the letters are on the left, I just switch the sides. Okay. Here we've got y minus 2 equals, our slope is negative 4/3, x minus 9. Here I will clear by multiplying through by 3. Clear fractions. And I get 3y minus 6 when I distribute. This clears the 3 there. I've got negative 4 times x minus y. When I distribute that, I've got negative 4x plus 36. I will add 4x to both sides. And I will add 6 to both sides. And I get 4x plus 3y equals 42. All right, let's take an example. X minus 5y equals 75. Our point is 0, negative 3. All right, so I need the slope and I don't have it. I will subtract x from both sides. I get negative 5y equals negative x plus 75. I divide by negative 5 on everything. Y equals, this is negative 1 over negative 5, which is positive 1 over 5. And 75 divided by negative 5 actually doesn't matter at this point, but it is negative 15. When I say it doesn't matter is because we're just looking for the slope that is parallel and perpendicular. Now that we have it, parallel will be 1/5. So I have y minus negative 3 equals 1/5 x minus 0, y plus 3 equals 1/5 x. I clear the fractions by multiplying both sides by 5. 5y plus 15 equals x. And if I subtract 5y, I get 15 equals x minus 5y. Or I put them in the other order and I have x minus 5y equals 15. My 5s look more and more like s's every day. I need to start writing better. All right, we look at the perpendicular line. If this is 1/5 perpendicular, we flip the fraction over and we make it the opposite sign. This should be m is -5. And now here I did y minus y. Here I used point slope. Here I'm not. Just to show you that we could have done this either way. This is the y-intercept. So the faster form is y equals mx plus b. Y equals -5x minus 3. I add 5x to both sides. I get 5x plus y equals -3. I don't know if you've noticed the coefficients here, parallel versus perpendicular, or parallel versus perpendicular. The coefficients are swapped. And one is negative, and one changes signs. The 5 was on the y, now it's on the x. The 1 was on the x, now it's on the y. This was negative, and now it's positive. We look at the same up here for these two. 4 was on the y, now it's on the x. 3 was on the x, now it's on the y, and the y, we had no negative here, we have a negative here. We can't use that to jump ahead because we don't know what this value over here would be. But it does make a pretty handy check if you're looking for parallel versus perpendicular. Okay. Let me give you guys one to try. This is example 4, I think. 3x minus y equals 6. And we're going through the point. Negative, oh, look at that. -2/3 7. Ah, what an asshat. Jones, you're an asshole. I know, I am. But I know I am. And I embrace it. All right, I'm going to assume you did this. I can find this in slope-intercept form quickest by adding y to both sides and subtracting 6. And I get 3x minus 6 equals y. So m is 3. If I do parallel, y minus 7 equals 3 times x minus -2/3. So this is my parallel line. Y minus 7 equals 3x. I distribute the 3 and it cancels when I get over here. And I just have +2. I want to keep my x positive, so I'm going to subtract y. And I'll move the 2 over. I have -9 equals 3x minus y. Or if I change the order, 3x minus y equals -9. For the perpendicular line, we flip the slope and make the opposite sign. So y minus 7 equals -1/3. x minus 2/3. X minus negative 2/3. So plus, I will clear fractions by multiplying both sides by 3. At least the outer fraction. I get 3y minus 21 equals, I now have negative times x plus 2/3. So 3y minus 21 equals negative x minus 2/3. I'm going to clear fractions again because standard form doesn't have fractions in it. This is 9y minus 63 equals negative 3x minus 2. Now I can add 3x to both sides and 63 to both sides. And I get 3x minus 9y, or plus 9y, equals 61. So these kind of have them swapped if I divided by 3. Something else to notice? Notice if I look at the original line and I look at the parallel line, everything is the same except the right-hand side. That was the case on this one too. X minus 5y, x minus 5y. You don't see it as well when you start in non-standard form. But the standard form for the parallel lines, everything should look the same except C. That doesn't help you get C, but it does speed things up. Actually, it could. Oh, let's think this out. Could we speed this up? Could I speed up the parallel lines knowing that that stays the same? I have 3x minus y. I don't know what this value is. Let's call it C. Let's plug in negative 2/3 and 7. And that's my C. So 3x minus y equals negative 9. Bam! Fast forward on parallel lines. You're better off doing this. It's better practice, especially since that's how perpendicular works. You don't have a cheat mode on perpendicular. So this is like faster way for parallel. But don't do it. It is the good to use as a check. All right. What about this? One more problem, and then we'll have a separate video for the final topic, which is similar to the collinear idea, but not quite. Final example. Y equals 1.4x minus 2. So, oh, and 0.10. So m equals 1.4. And to get to the fraction easy, clear the decimal by multiplying by 10 over 10. That causes this to move the decimal right once. And I get 14 over 10 or 7 over 5. So parallel will have the same slope. y minus y1 is 0. I will clear fractions by multiplying both sides by 5. So this is the parallel equation. I get 5y equals 7 times x minus 1, which is 7x minus 7. And now I want my x to be positive. It's already positive. So I'm going to subtract the 5y to the right and add 7 to both sides. And I get 7 equals 7x minus 5y. Or I can change the order and do 7x minus 5y equals 7. I can see the slope here for the parallel or perpendicular line is negative 5 over 7. If I tried to do 1 over this and make it negative, look what happens. This is an unending decimal. No, it looks like it might be repeating. I see 714 again. But that's not helpful to do for the slope or do this slope intercept form. It's definitely not going to help when you're trying to do here and you have unreliable results. So you're better off converting to a fraction to do the parallel and perpendicular. So we've got that here. Perpendicular y. Again, we had no y minus 0. I'm just going to go straight to y. Equals negative 5/7 times x minus 1. I will multiply through by 7. And that will clear the fractions. I will distribute. And then I will add 5x to both sides. And I get 5x plus 7y equals 5. So that's plenty of practice doing parallel and perpendicular lines. We've got one more video in this topic, in this chapter. We're almost done with chapter 6. Peace.